Good morning, students. Today we are going to discuss about construction of an AVL tree as we discussed in the BST. Okay, now let us take this sequence of number 14, 17, 11, 7, 53, 4, 13, 12, 8 and we have to build an AVL tree. Initially an AVL tree is an empty. Now let us take insertion one at a time and then repeatedly we construct an AVL tree. While you do so, in any cases, after inserting a new node, if the violation happens in an AVL tree, then we will try to apply the rotations. Now let us take one by one and then let me show how the insertion in AVL tree happens. Initially an AVL tree is empty. So now let us take the node 14. Node 14, we will make that node as a root node. Okay. Now let us take next node, which is 17. Since 17 is larger than 14, it will go to the right side of 14. Okay. Now let us take 11. 11 is lesser than 14, so it come to the left side of 14. So we have inserted 14, 17, 11. Now once we insert, let me check the balance factor. So the balance factor for this is 0, for this is 0, this is 0. So up to this, it satisfies us the properties of AVL tree. Now let us take a new node, which is 7. Where does that it go? 7 is lesser than 14. So 7 is lesser than 11. So now it has reached in its right position. Now let us calculate the balance factor for this newly inserted node. This is 0 and then this path, okay, is the one which has been insertion happened. So 1 minus 0, this is 1, and then 2 minus 1, this is also 1. Okay. So no problem. Now let us take another node insertion, which is 53. Now let us see where that 53 goes. 53 is larger than 14 and then 53 is larger than 17. So after inserting, do the calculation balance factor for 53 0. Now this is minus 1 and now for this is height is balanced, right? Now this is 0. Okay. Now let us take the next node, which is 4 over here. Okay, 4 lesser than 14, lesser than 11, lesser than 7. So 4 is reached in its right position. Now after inserting 4, let us calculate the balance factor. For this is 0 and for this is 0 and this is 1 and for this node it is 2. Okay. Now for this node 1, 2, 3 minus 2, which is 1. Now you see this node, okay, as long as the balance factor is violated, you have to fix that node as A. So fix that node as B. Now from after inserting, you look at from the bottom to top. Balance factor is satisfied for this node, balance factor satisfied for this node, but here the violation happened. Now this is nothing but your P, right? Once it is P, this is your A. Okay. Now you see this is in the left to left. So left to left insertion happened. This is similar to case 1. So apply case 1 rotation here. Case 1 rotation says that you rotate in the P position in the right direction. How many rotations you should apply? Only 1. Okay. Now let us draw after rotation. Okay, 7 will go here, 11 will come here, and then 4 will go here, and then 14, and then 17, and then 53. Okay. So now this is the right tree. Let me draw 7, 4, 11 neatly. So here this is node 7 and then this is 4 and then this is 11. Okay. Now what is P here? P have moved here. Okay. What is A? This is A. Fine. We have applied single rotation. Now let us calculate the balance factor for every node. 0, 0, 0, here -1, here 0, here 0. Okay. So it maintains the AVL property. Now let us insert the next node, which is 13. 13 is lesser than 14, greater than 7 and then greater than 11. So 13 will get inserted here. After inserting, let us calculate the balance factor. For this is 0, for this is -1, for this is 1 minus 2, which is -1, right? This is 1, 1, 2. Okay. This is -1, 1, 2, 1, 2, 3. 3 minus 2, which is now, this is 3, 3 minus 2, 1. Okay. This is 1. Okay. Now it satisfies the balance factor. Now after inserting the node 13, it satisfies the properties of AVL tree. Now let us take another node whose value is 12. Okay. Now let us take 12. So the right place for 12 is lesser than 14, greater than 7. 12 is greater than 11 but lesser than. So 12 is getting inserted over here. Now after insertion, let us calculate the balance factor on the path that it has reached. Okay. After inserting a new node, now this is the new node. Now let us calculate the balance factor. For this is 0 and for this is 1 minus 0, which is 1. Okay. Balance factor for this is 1 and then okay, balance factor for this is node is 1 and for this is, what is the balance factor? 0, 1, 2. So this is -2. Okay. This is -2. Now for this node 1, 1, 2, 3. Okay. So 1 minus 3, which is -2. Okay. Fine. Now here 1, 2, 3, 4. 4 minus 1, 2, 3, 4. 4 minus 2, which is 2 over here. Okay. So in all the places the balance factor is updated. Here it is -2. Here also it is -2. Fine. Now let us figure what is P and then which type of rotation required in this case. Now you see this is P. Okay. Because from the bottom, this is the node whose balance factor is affected, which is -2. As long as you figure P, okay, now this must be your A. Okay, and then this is your B. Okay, now you look at the case, in which case it is there. Now this is in the right and then left. This is, recall your case 4. Okay, when the insertion was happened right now 12, that was happened in the right and then left of the node PA. Now this could be B directly. Fine. Now you have to apply the rotation 2 times. What are those rotation? Right, left rotation, but you have to apply right rotation here first. You have to apply right rotation here and then left rotation over here. Okay, now let us do that right left rotation. Here, suppose if you do rotate in the right, what we will get is that 12 will go here and then 13 will come here. No change in P. Now let me write, this is your B, this is, sorry, what is B here? 12. This is B, 13 is A. Now this is your P. Okay. Now the remaining node will connect as such. So let me draw that 7. 7 left is 4. And then 14 is the root node. Then it has 2 children, 17 and then 17 and then 53. Fine. Now one more steps we have to do. What is that? We have to rotate here in the, we have applied right rotation. Now we have to rotate here in the left direction, so that B will come to the root node, B will go down. Okay. So let me erase this portion. So once we rotate, B will go here. So let me draw that first. 12. Then once 12 come, 13 will go here and then 11 will go here. Let's figure out these things first. Now this is your B. Now this is your A. Now this is your P, right? Then you insert the other nodes as such. So 7 will be its node. Okay, node 7. 7 is having the left child, which is 4 over here. So no change. Now go to one level up, which is 14. 14 left is 7 now, and it has the right children, which is 17 and then 53. Okay. This is the step after 2 rotations, double rotation. Now let us calculate the balance factor for every node. Okay, now this is 0, 0, 0, 0, 0. Now balance factor for this is 1 minus 2, which is minus 1. 1, 2, 3, 3 minus 2. 1 for this and then minus 1. Note down, balance factor is maintained for every node. Now this tree is satisfied. Now it is an AVL tree. Now let us proceed inserting the last node, which is 8. 8 goes left of 14, greater than 7, less than 12 and then less than. So the right position to insert the node 8 is here. Now let us calculate the balance factor. 0 for this and then for this is 1, and then for this node is 2 minus 1. Okay, so the balance factor is 1 for this. Now you look at this, 1, 2, 3, 1. Okay, for this node is, sorry, left side is 1, 1, 2, 3. Okay, so 1 minus, this is 1, 1, 2, 3. 1 minus 3 is minus 2. Okay, as soon as you see that there is a violation in the balance factor, you fix that. So there will not be any error. So this is P. And then you have to update the balance factor for this node 1, 2, 3, 4 and then 1, 2. So the balance factor for the root node is now 2. Okay, this is minus 2. Okay, now you see the case and what we have to do. So the insertion, what was the new insertion? The node 8. So this is the new node insertion, which is 8. Where does it inserted? In the right and the left. So it's easy to say that this will be your A, because right side is A, this is your A, and this is your B, right? Now we have to apply rotation. Which case? Again case 4, okay, because it is in the right left. This is right, this is left. Insertion was happened right to left, but we have to apply the rotation twice. First you apply right rotation followed by left rotation. Right rotation you have to apply here, and then left rotation you have to apply here. Okay. Now let me take that procedure first. Right rotation, if you do right rotation for this, 11 goes here, and then 12 comes here, 13 will go here. As long as you apply rotation, you fix that what is A, B, so that there will not be any error. So now what is 11? 11 is your B, this is B, and this is your A. Okay. Note down, subtree of A moved over here, and then what is left? 8. Okay. B have moved here. Now you copy P. P is here. What is your P? This is P. Okay. No change in the P's left. So 4 have moved in its right position. And then 14, let me copy this P here. Okay. This is P. And then 14, 17, and then 17, 53. Okay. Now I have to move 8. 8 has to go in this position. Okay, left of 11, where does it go? Here, in this position. Okay, now after this I have to apply rotation here, where? In the left direction. Sorry, there is a mistake. 8 is left. What is left? 8, right? 8 is nothing but the left side of node B. Okay. Now left side of node B, it is there. This is B, and then we should insert node 8 here. Okay. After inserting, note down PBA is the resultant of the first rotation. Now we have to apply one more rotation in the left direction with respect to P. So now let us do that and then show the resultant of that. Okay. Now you rotate in the left direction so that 11 will come in the root node. So this is 11. Okay. This is 12. So what is 11? This is B. And now this is A. Now this will go to 7. So you fix this first. Now you see P is the root node, B is the left, and then A is the right child. Okay. Once we figure this correctly, then you can attach all its subtrees in the right position. Okay. So you take this A right will go here, which is 13. And then 7 left will go here, no changes. Okay. Now 11 left child is 8. Okay. So now where we have to insert, it should be lesser than 11. So you see lesser than 11, but this is greater than P. Okay. So this is the case that we have discussed. So greater than P. So we can insert this in this position. Okay. What is that? BL. BL has moved to the right side of P. This is the case exactly we discussed in the case 4. After that, so once this is done, you have to connect the remaining part of the tree. So which is 14. Now this is my B, and now this is my 17 and in the next node which is 53. Okay, so node 8 was inserted successfully. Now let us calculate the balance factor for this. So 0 0 0 0 0, for this is minus 1, for this is 0. Why? Because 1 2 1 2 1 2 3 3 minus 2 1 for this, and this is minus 1. Note down, every node satisfies the condition of balance factor. Now after inserting node 8, the tree is now balanced. So the final AVL tree after inserting every node is this. Okay. Now let us discuss deletion part.